Welcome to the Kicking Off Fourth Grade Math Workshop. I'm Megan from the Math Workshop. I'm so happy that you're taking time to take a deep dive into all things fourth grade math. My hope is that we will add to your toolbox of ideas and activities to support your mathematicians and help you set the stage for a great year of learning. Let's take care of a little housekeeping first. Within the email where you received the link to this recording, you should have also located a note-taking guide that you can feel free to use to take notes during this workshop. Do what works best for you. Perhaps you want to digest this workshop in chunks, so you want to stop it and start it. Maybe you want to rewatch it. Maybe you want to watch it all at one time. It is about 2 hours in length. Additionally, you should have seen in that email a math routine sampler slide deck full of the math routines that we're going to talk about in this workshop, 3 math games, and a set of geometry word wall cards, and a certificate of completion of this math workshop. In that same email, you should have also seen a link to a Survey Monkey feedback form. Oh boy, we would really appreciate after you watch this workshop, any feedback and all feedback we welcome. So thank you in advance for considering filling it out. Let me take a moment to introduce myself if we haven't met. My name is Megan Brewer, and I'm the creator of the Math Workshop. We support a community of mathematicians who believe that learning math to the deepest levels is possible for everyone. At our core, we're committed to making mathematics learning fun and engaging while ensuring that all instruction centers around making sense of concepts. We provide the tools and resources for students of all ages, big and small, including hands-on manipulatives and visual aids that help unlock the connections and relationships between mathematical concepts. We believe that learning through investigations provides the framework for developing essential problem-solving skills and critical thinking skills, which are so important, while promoting a growth mindset. I'm a former elementary school teacher. I was a math coach at a Title I K through 6 school. I worked for a large school district in the curriculum office, where my job was to share research-based strategies with teachers in our district to support their multilingual students so that those students would have access to grade level mathematics so that the mathematics wasn't watered down. I've also worked as an educational mathematics specialist, consultant, traveling the United States, teaching courses, math courses, workshops for teachers, administrators, coaching teachers, doing model lessons and working with students while teachers observed. And I've also worked as a curriculum designer and editor. But now my favorite current roles are teaching students in my own local community and supporting educators and parents as they teach their children math, as well as supporting those groups virtually. I currently live in North Carolina and I'm a mom of 2 teenagers. I have lots of fur babies in our house. I love to travel the world and I am a voracious reader. And thanks for listening as I share about myself. Let's continue on. Here's our webinar agenda. We're going to explore the 4th grade math standards. We're going to examine the math tools, manipulatives, and representations to support your standards, your students' understanding of the standards. And we're going to share some of those math routines that I talked about. Sound good? All right, let's start off with exploring the 4th grade math standards and tools. We're going to combine these together, which seems to make sense because as we explore a standard, we can talk about what are the math tools and the representations and the manipulatives that would support students' understanding around that standard. Well, let's start with these are the 5 domains for the 4th grade math standards. We have operations and algebraic thinking. We have number and operations in base 10. We have numbers and operations and fractions. We have measurement and data, and we have geometry. Here are the big ideas of 4th grade math that students will develop an understanding and fluency. We're going to talk about that word with multi-digit multiplication and division. Students will develop an understanding of fraction equivalence. Students will develop an understanding of addition and subtraction of fractions with like denominators. Students will develop an understanding of multiplication of fractions by whole numbers and develop an understanding of geometric figures, which can be analyzed and classified by properties. So during this math workshop, we're really going to focus on these 3, okay? Let's go back to that word fluently. So in the first big idea, developing understanding and fluency with multi-digit multiplication and division. What does that really mean? Here's what it doesn't mean. It does not mean time test. That is not what they're talking about. When they say fluently multiply and divide within 100, they're talking about 3 keywords, and they are efficiency. That's solving a procedure in a reasonable amount of time by selecting an appropriate strategy and readily implementing that strategy. Flexibility, that's knowing multiple procedures and applying or adapting strategies to solve procedural problems. So that means I have a plethora or a toolbox full of strategies for solving maybe an addition problem. And when I see an addition problem, I have the ability to go, which strategy would be efficient and would really work best in this situation? And then, of course, accuracy. This is math class. That's correctly solving a procedure. All right. Well, let's unpack the 4th grade math standards. As we explore the standards, we will make them applicable with examples. Feel free to pause this math workshop if you want to take notes while we're going through these. We believe it's essential to stay focused on what our standards are. Because we often know, this is what I found traveling the country, that different curriculums and different programs or other resources we might use, sometimes they go below our grade standards, and lots of times they go above our grade standards. And sometimes they're not really showing the mathematics to the intent of the standard. So it's really important for us to be discerning consumers of whatever curriculum we choose to use, meaning that we're staying focused on the language and expectations of the grade level math standards so we can best support our students. All right, so let's first focus on the multiplication and division standards. 3rd grade was the first time that students officially worked with multiplication and division, though in 2nd grade, there are 2 standards which lay the foundation for multiplication. This is 2nd grade. It's understanding repeated addition. So 3 plus 3 plus 3 is 9. So they're laying that foundation for 3 times 3 is 9, which is 3rd grade. And also there's another 2nd grade standard that has to do with arrays. So students might be looking at inch tiles that are arranged in columns and rows. Maybe it's a 3x4 of inch tiles, and students are figuring out through addition that it is 12. So that's building the foundation for 3rd grade, which would be 3 times 4 is 12. So that's just to let you know what was before. So, as we're thinking about multiplication, let's watch a fantastic video from Graham Fletcher on the progression of multiplication, which will really help us think about how to best support our fourth grade students. This video will also share with us what instruction our students should have had leading up to fourth grade, which is going to help us because we know sometimes maybe students miss that instruction, or maybe they need more time with those big ideas. So we can help them. All right, let's go watch this video now. Let me get us there. All right, here we go. There we go.
So here's my attempt to explain the progression of multiplication. Well, most of us might think it starts in third grade, but in actuality, it starts in second grade, where students are expected to take a square or a rectangle and partition that square into no more than 5 rows or 5 columns. Here, the understanding of repeated addition is established. 5 plus 5 plus 5 plus 5 plus 5 is 25. Then, in third grade, students take that understanding they've begun to develop in second grade and begin to construct arrays using square colored tiles, or any manipulative for that matter. The important piece is once they've actually constructed that model, they draw a pictorial representation which matches their model. Here we have 4 rows of 6, or it could also be seen as 6 rows of 4, depending on how you turn the model. And the big piece here is that we don't push an understanding on students, we let students explain what their model represents. The big piece is that the context will explain the equation, not the teacher. Then we take that understanding and we come back to the biggest piece probably in third grade, which is that there's a relationship happening here. And that relationship is taking place between multiplication and division. Take this, for example. 12 divided by 4 is a number. 4 times what number is 12? Well, if we take 12 tiles and we put them in 4 rows until we run out, we actually see that we have 3 in each row. So there's a connection between multiplication and division, and arrays can be used for both. The context. Yep, let's go back to it. Here's a simple one. There were 3 packs of pencils. Each pack had 40 pencils. Well, at the beginning part of multiplication, students might do something like this, where they draw out 3 circles, and in each circle they put in 4 10 rods, so 40. Or they could actually go ahead and draw 40 little pencils. That's great. But the standards of mathematical practice, and in particular number 7, want us to be efficient. And one way to do that is we can begin to make use of structure. And when we do, we make sense of it. Here we begin to create an area model for multiplication, very much like an array, just on a bigger scale with larger numbers. So 3 times 40, we take it, build it out of 10 rods. We have 10 tens, which is 100, plus 20 is 120. Or it could also be seen as 12 tens. Really big understanding for students. Once students have established this, they should be diving into drawing pictorial models for what they're concrete. Again, we don't want them to be sitting there with manipulatives all the time. So we move them away and they begin to draw a pictorial representation for what their concrete model looks like. Then from there, we'll have them use numbers to represent their picture. All of the time, connections are being made. Then, eventually, after multiplying all of these ones and tens, students begin to collect and group numbers together. Now we're beginning to become efficient thinkers. The connections are being made all around because students are exploring. In fourth grade, students are expected to multiply 2-digit by 2-digit numbers. So what does this look like with a concrete model? Well, it kind of looks the same, really. So we have 23 across the top and 22 down the side. 10 times 10 is 100, and that's where those 100 plates come into play. Then, once students have gone ahead and actually built a model, they see that they have 400s, 10 tens, 6 ones, and they add that all together, 506. Then, just like we did with smaller numbers, we expect that students should draw a pictorial representation which matches their concrete model. You can see the 100 plates, the 10 rods, and the 6 ones. There they are. Altogether, 506. Then, just like before, we'll ask that students go ahead and start using tens and numbers to actually represent their model. So what you're probably thinking right now is this is not efficient. There's too many tens going on here, too many ones, and students are going to get confused. And you know what? You're absolutely right. And it's at this point where kids say, this sucks. We need to find a shortcut. So what do? They begin to group and collect their numbers just like they did before. So here we have the box method. But in reality, it's partial products. So let's not call it the box method anymore and start calling it by its real name. Then we take that partial product understanding and we begin to formalize it into some kind of standard algorithm. Yep, this is a standard algorithm. It's a series of repeated steps. And you can see where each of the numbers come from. Then we have the algorithm that we're all pretty much used to. But you see that 0? Now the connection is made and students know why we magically put that 0 there. But all this understanding happens at the end of 5th grade. Let's not rush them. There's so much happening here and so much to explore. Let's slow down a little bit. Let's continue the conversation. Join me on Twitter, and thanks for watching.
Wasn't that a fantastic video? Sorry about that. All right, move this back over and back over here. Okay, let's keep going. Wonderful video. If you feel like you want to watch it again, I know I've watched it numerous times and I pick up something additional each time. Continuing on. So Mr. Fletcher mentioned the CRA model of teaching math. This model has its roots in the work of psychologist Jerome Bruner. Bruner's theory of cognitive development, specifically his stages of representation, heavily influenced the development of the CRA model. The CRA model is a 3-stage learning process where students first experience concepts with concrete objects, then move to pictorial representations, just like Mr. Fletcher was showing us, and finally moving to abstract symbolic notation. That's numbers and symbols. And while Bruner's ideas laid the foundation, the CR8 model was further developed and popularized in the 1980s, with Singapore's Ministry of Education adopting it as a key teaching strategy. So C, concrete, R, representational, A, abstract. Here's a visual model to help us really think more about the CRA approach. Notice that the bottom level of the pyramid is a foundational level. This lays the groundwork for students thinking about any concept or operation. This is where we should be instructing students first through hands-on math tools, concrete objects, or manipulatives. The M&Ms in the bottom left side of the slide of the screen are modeling 3 groups of 3, or 3 times 3 is 9. Also, the red and blue clothespins on the bottom right side of the screen are modeling 3 red clothespins and 2 blue clothespins equaling 5. Once students have had enough time exploring the concrete models of operations and math concepts, then we gradually move them to the representational model, those pictures and drawings which represent what we were doing hands-on. Here we're sketching what we were doing. And since we've had that exposure to the concrete models and tools to solidify our thinking, now moving to a sketch or drawing to represent our thinking makes sense. And it's a beautiful progression. We see the 3 rows of 3 circles on the left side of the screen modeling 3 times 3 is 9. And the 3 red circles and 2 blue circles on the right side of the screen, modeling 3 plus 2 is 5. Lastly, we move to the abstract level. That's the numbers and the symbols. Now that we truly understand the concept or the operation, we can just move to representing those ideas with numbers and symbols. Another model that's typically used by math educators that's related to the CRA model is the Lesch model. The Lesch model is also known as the Lesch translation model. It originated from the work of Richard Lesch in 1979. It's a framework in mathematics education focused on the importance of understanding mathematical ideas through multiple representations and the ability to translate, move back and forth between them. So let's look at let's unpack this for a moment. Notice that all 5 of the representations have lines, arrows going back and forth amongst all of them. So the concrete, or the pink circle, which says concrete, is the same as the C in the CRA model. The visual, or the orange circle, is the same as the R, the representational, in the CRA model. The S, symbolic, sorry, the yellow circle, the symbolic, is the same as the A, the abstract, in the CRA model. That's using numbers and symbols to represent mathematical concepts and operations. Now, here's the new part. The green circle, that's the verbal model. That's where we would have discussions in math class. Well, we're facilitating the discussions. Students are having the discussions. They're explaining their thinking, or we're inviting them, giving them the opportunity to explain their thinking, their reasoning, justifying their ideas. The teal, that says contextual model. That's all about story problems, word problems, putting the operations and math concepts into a real world context. For example, if I wanted to share 36 cupcakes with 3 classes, how many cupcakes would each class receive? We really see the benefit of the Lesch model as students are exploring mathematical ideas, concepts, and operations with all of the models. Then they're going to really understand the math they're learning. Okay, I think we need to pause for a moment before we look at the math tools and take a breather. I think we need to be gentle with ourselves. Most of us probably did not learn mathematics in elementary school with many math tools. I know for myself, I don't remember a tool, not one. And I'm here to share that I mostly did not know why I was performing the steps for the algorithms I was using. I tried to memorize my facts, multiplication facts, addition facts. I tried. And I tried to remember the steps in the algorithms, long division algorithm, multiplication standard algorithm. I tried. But honestly, I personally made a lot of mistakes because I wasn't sure why I was doing what I was doing or what it was all about. So today's math standards call for students to blend procedural knowledge. That's the way I learned, and maybe you too, memorizing those facts, memorizing steps and algorithms. But today's standards say students will learn with a blend or a balance, procedural understanding and conceptual understanding. So when I was growing up, and maybe you too, this is what was missing. I didn't have the conceptual understanding. Our teachers weren't instructed to spend time using models and tools to help us really understand what is addition. Oh, it's the joining of items or the composing of items or numbers. What is multiplication? Well, it's really repeated addition. Here's what it looks like. That's not what I heard when I was in school. I don't blame the teachers. That's just not what they were instructed to teach us. But today's standards say students should learn with a blend of both. So let's be honest with ourselves. We are asked to teach in a way that's different than we're taught. So we need to be gentle with ourselves. We're on a journey as we explore these math representations, tools, manipulatives that are going to help students build that concrete understanding. And then they can move to the sketching and the picture drawing that related to using those hands-on tools. And then finally, when they move to the abstract, that's just solving problems with numbers and symbols. Now it makes sense to them. They're less likely to make mistakes. And because they have true understanding, they can really move on to higher level mathematics. Well, here are the top reasons that teachers share across the country. They share with us why they do not provide math tools. Let's take a moment and look at these. Number one, we don't have time. Number two, I don't know how and why to use them. Number three, my students can't handle them. Number four, well, I didn't learn that way, so why should my students? I'm fine. Number five, they can't use the math tools on the end of the year test, so why should I let them use it during the year? Okay, let's talk about these for a moment. Number one, we don't have time. Our response is, how can you not take the time for real learning and real understanding? If we don't provide those math tools, most likely students aren't really going to grasp the concepts. And so we're going to have to do a lot of reteaching every year. And that's what we're honestly seeing in education. And it's for a multitude of reasons. But one is if students don't really understand the concept or the operation, then we're just going to have to keep reteaching. So we need to take the time. Real learning takes time. Take the time. Number two, I don't know how and why to use them. Well, hopefully, watching this math workshop and others that we have will help. Hopefully, that's what we're hoping. That's our goal. Number three, my students can't handle it. Okay, we have a slide coming up next that has tips for implementation of math tools. Number four, I didn't learn that way. Well, here's our response. Research shows that most people learn best through tactile, hands-on, and visual representations. So though we might not have had access to these kinds of tools, research has shown it helps students and adults. So let's use them. Last one, they can't use the math tools on the end of the year test in most cases. That's true. Why use them during the year? Seems like a valid reason. However, because the students have used the math tools during the year, so that concrete level, then you've helped them scaffold and segue into using sketches and drawings. When they get to the test, and whether it's on a computer or laptop, but they have scratch paper, or if it's a paper test and they have scratch paper, they are able to do well. This is what we have found. They're able to do well on the assessments because real learning took place. So we supported them through the year to demonstrate at the end of the year that they really understand the fourth grade math standards. All right. So here are some tips for successful implementation of math tools. Give explore time every time. So every time I use a manipulative with a different set of students, I give them, maybe it's just 2 minutes, it's not long, and I let them know, hey guys, this is your explore time. I'm going to set the timer right here. Here's your 2 minutes to just feel this tool, stack it, turn it around, examine it. So I'm honoring and respecting their natural curiosity and giving them that time. And then when the timer goes off, I say, all right, we're going to use it as a math tool now. And we set the stage for what we're going to do. The next one, setting clear expectations. We see that teachers who successfully use math tools across the country set clear expectations. This is how the tool will not be used. So for example, I'm pulling up in my brain geoboards and rubber bands. So sharing right away with students, rubber bands will not go flying across the room. First of all, that's a big safety concern if it was to hit someone in the eye, and I will even say that. And secondly, that's just not how we're going to use this tool. And if you do choose to use the tool that way, you will lose the privilege of using that tool. And most of the time, honestly, students want to use the tools. They don't want to be penalized by just losing that right and just sitting there and watching their classmates. So usually that works. The next one, modeling usage, modeling how we're going to use this tool. And last one, considering storage. So this is a really personal one. You know, what's your budget? What's your space? What works best for you? We have seen that some teachers like to provide that first image on the top of the screen, individual math toolkits for students that contain the tools that would support the learning of whatever operation or concept they're currently studying. They might even have a helper job to replenish or switch out the manipulatives in that toolkit whenever it's pertinent. Sometimes we've seen teachers have in the other image bins, plastic bins. Sometimes there's one for each table group. Sometimes we've seen teachers effectively put the items in baggies or again within those bins so it's quick to pass out to table groups or partners. And again, that could be a helper job. So just thinking about not wanting to lose instructional time by passing out and collecting, really trimming that down, what would be effective and efficient. All right, let's get into some of the tools. In fourth grade, there's many multiplication and division standards that we're about to look at. Inch tiles can be a fantastic tool to help students understand the concepts of multiplication and division. So, however, though, when students start operating with larger numbers like they're going to be doing in fourth grade, you're going to want to, inch tiles become too cumbersome, and you just would have to have too many, which starts just not working. So then you're going to move to our next tool, which I'm going to share with you in a moment. But I just wanted to pause and let you look at the top image of multiplication with the inch tiles and the bottom image, which is more of a sketch with division. All right, so the next tool we really recommend, especially because fourth graders are working with larger numbers, is grid paper. So grid paper can be great for modeling what we would be doing with um, multiplication and division. Centimeter grid paper. So we have to be cognizant, of course, of how many squares there are in the columns and rows, and does it match what is needed with the multiplication and division problems. Because then, of course, as Mr. Fletcher was sharing, we're going to move to students just sketching with the box, that partial products and quotients. Number lines can be a fantastic tool. I mean, we're starting to use, of course, number lines really start in kindergarten. We call it a number path. It's a little bit different, but really first grade, second grade, we're really getting into number lines. So in fourth grade, number lines still should be going strong to visually represent numbers. We can use them with fractions, with decimals. You'll see two examples right there of an open number line. The only difference between a traditional number line, which is the top and the bottom on your screen, and the open, the two in the middle, is the traditional has all the ticks of the labeling of the numbers that it's representing. An open number line, we can be flexible. For example, we're showing how from 37 to 77 is a jump of plus 40. So we can be flexible and we don't have to put all the tick marks or the hash marks. We're modeling and showing how we can move along the number line, whether we're doing addition, subtraction, multiplication, division, whatever we're doing. Students really benefit from seeing the teacher probably in the beginning modeling how a number line can be used, and then they just run with it. It's fantastic. It's a tool I don't think I was exposed to in elementary school. I wish I had been because it's really opened up my own learning. It's a great tool. On the slide, you will see physical base 10 blocks up on the top right. And then we have more pictorial representations of those blocks. So again, students can transfer that concrete to pictorial and then abstract. So one of the standards for fourth grade math is generalized place value understanding for multi-digit whole numbers. Recognizing that in a multi-digit whole number, a digit in the ones place represents 10 times what it represents to its right. For example, recognizing that 700 divided by 70 equals 10 by applying concepts of place value and division. Grade 4 expectations in this domain are limited to whole numbers less than or equal to 1 million. Let's look at another fourth grade standard. Generalized place value understanding for multi-digit whole numbers. Read and write multi-digit whole numbers using base 10 numerals, number names, and expanded form. Compare two multi-digit numbers based on meanings of the digits in each place, using greater than, equal to, and less than symbols to record the results of the comparisons. And I'll give you a moment to process what's on the screen with the base 10 blocks, the number names, and the expanded form. Generalize place value and understanding for multi-digit whole numbers. Use place value understanding to round multi-digit whole numbers to any place. So again, that number line can be a very powerful tool in showing students what's the distance from that nearest 10 or nearest 100 or whatever you're having to round to. It's about the distance. But then at some point, we do have to talk about the 5. And of course, the 5 is an equal distance from both sets of the 10. So mathematicians made a decision to round up to the nearest 10. When we're dealing with that 5, we're going to round up. That it is, we really want to be honest with students, it is, and we want to give them opportunities to discover this and have a little discussion around it. Gosh, what do we do when it's a 5? It's 25 or 35 or whatever. It is that equal distance. So mathematicians did make a decision. We're just going to do this. But sometimes in a context, we can talk about that with students, whatever it might be a different context where rounding down might be more pertinent. But again, so in real life, maybe that's what's realistic. But again, formally, mathematicians have decided we round up. Let's look at another one. Use place value understanding and properties of operations to perform multi-digit arithmetic. Fluently, ooh, there's that word. Remember that? Efficiently, flexibly, and accurately. Fluently add and subtract multi-digit whole numbers using the standard algorithm. Ding, ding, ding. This is the first time the standard algorithm has shown up in math standards. Of course, students from kindergarten on up to fourth grade are adding and subtracting. They are, but their standards call for addition and subtraction to be taught through conceptual understanding. They're asked to add and subtract using strategies based on place value, strategies. There's a multitude of different strategies for addition and subtraction, and we do have an on-demand workshop about that if you want to explore them. But also they're asked to add and subtract using the relationship between addition and subtraction, that inverse relationship. So for example, if I need to figure out 10 take away 7, what is that? But I know 3 plus 7 is 10, I can use that relationship to figure out the answer. They are also asked in the lower grades to use models, pictures, and tools to add and subtract. So they're making sense of those operations. So in fourth grade, students are now using or expected to use the standard algorithm for um, addition and subtraction. So there's an example on screen or examples. I still have to share for myself, though, that middle example, 200 take away 189, and I know I'm not alone on this one. Still trying to remember all the rules for zeros sometimes drives me batty. I would much rather use, for me, a more efficient standard, so 200 take away 189, of just simply adding up from 189 to 200 because they are so close to each other. So you could see on my open number line example, I just made a jump from 189 to 190. That's a jump of 1, and a jump of 10 from 190 to 200, and 10 and 1 is 11. And I could do that mentally, and students can too when they're shown this thinking in seconds, and I don't have to remember all the rules about the zeros. So that's a example of an efficient strategy that makes sense. And maybe I'm less likely to make mistakes using the crossing out the zeros and the trading and all that. All right, let's look at another one. Generate and analyze patterns. Generate a number or shape pattern that follows a given rule. Identify apparent features of the pattern that were not explicit in the rule itself. For example, given the rule add 3 and the starting number 1, generate terms in the resulting sequence and observe that the terms appear to alternate between odd and even numbers. Explain informally why the numbers will continue to alternate in this way. And there's an example with -4 and also a shape pattern. You could have so much fun with patterns. In our materials that we have on our website, we have some great visual pattern math routines. Let's look at another one. Use the 4 operations with whole numbers to solve problems. Multiply or divide to solve word problems involving multiplicative comparison. For example, by using drawings and equations with a symbol for the unknown to represent the problem. Distinguishing multiplicative comparison from additive comparison. I'm going to be quiet for a moment and let you digest how multiplicative comparison is different than additive comparison. Multiplicative comparison is a way to compare two quantities by stating how many times larger or smaller one is than the other. It's essentially using multiplication to express the relationship between two amounts. For example, if one quantity is 3 times as many as another, you're using multiplicative comparison. Additive comparison in math involves determining the difference between two amounts by stating how much more or less one is compared to the other, often using addition or subtraction. It focuses on the difference between quantities rather than how many times greater one is over the other, which is multiplicative. We can see the bar model in both examples on the screen, which can be used in our drawings. And we see the equations. Let's look at another one. Use the 4 operations with whole numbers to solve problems. Solve multi-step word problems posed with whole numbers and having whole number answers using the 4 operations, including problems in which remainders must be interpreted. Represent these problems using equations with a letter standing for the unknown quantity. Assess the reasonableness of answers using mental computation and estimation strategies, including rounding. Let's look at this problem. Jose baked 18 cupcakes and plans to share them with 4 of his friends. He plans to keep the rest for himself. How many cupcakes will Jose have left after he shares his cupcakes? You see a letter standing for the unknown quantity. You see we have a remainder, and in this situation, it's a leftover 2 cupcakes. Mental computation or mental calculation is the process of performing arithmetic calculation entirely in one's head, mental math, without the aid of external tools like calculators or pen and paper. It involves using mental strategies and number facts to arrive at an answer, often relying on the decimal system and specific techniques tailored to different problem types. All right, let's look at another one. Use place value understanding and properties of operations to perform multi-digit arithmetic. Multiply a whole number of up to 4 digits by a 1-digit whole number and multiply 2 2-digit numbers using strategies based on place value and the properties of operations. Notice it does not say using the standard algorithm. So the standard algorithm is only showing up in 4th grade for addition and subtraction. That's what I mean about empowering ourselves with understanding the standards, because maybe your 4th grade curriculum or textbook or resources you're using might be exposing students to the standard algorithm. That's not what's expected of them in 4th grade. It's expected that they really deeply understand multiplication through conceptually through using strategies. I'm going back to the standard based on place value and the properties of operations. Illustrate, that's that representational model of CRA, illustrate and explain the calculation by using equations, rectangular arrays, and or area models. Use place value understanding and properties of operations to perform multi-digit arithmetic. Find whole number quotients and remainders with up to 4-digit dividends and a 1-digit divisor using, again, there's no standard algorithm mentioned. So it's using strategies based on place value, the properties of operations, and or the relationship between multiplication and division. So again, maybe the problem is 64 divided by 8. What is it? And maybe I'm thinking, oh, not sure. Oh, wait. I know 8 times 8 is 64. So 64 divided by 8 is 8. So I'm using that relationship between multiplication and division to figure it out. Illustrate and explain the calculation by using equations, rectangular arrays, and or the area models. Sorry, I reread that twice. Use the 4 operations with whole numbers to solve problems. Interpret a multiplication equation as a comparison. For example, interpret 35 equals 5 times 7 as a statement that 35 is 5 times as many as 7 and 7 times as many as 5. Represent verbal statements of multiplicative comparisons as multiplication equations. This one really stumps a lot of educators. A lot of them are saying, what in the world? But this visual really unpacks this for us. How can we write 7 times as many as 4 as a multiplication equation? I'll give you a moment to process that visual. Do you see the 7 groups of 4? It's amazing to me how a visual can really help us unpack that language. Let's look at another one. Gain familiarity with factors and multiples. Find all factor pairs for a whole number in the range of 1 to 100. Recognize that a whole number is a multiple of each of its factors. Determine whether a given number in the range 1 to 100 is a multiple of a given one-digit number. Determine whether a given whole number in the range of 1 to 100 is prime or composite. So really understanding factors, multiples, prime, and composite. Factor pairs are two numbers that when multiplied together result in a specific product. For example, the factor pairs of 12 are 1 and 12, 2 and 6, and 3 and 4. Because 1 times 12 is 12, 2 times 6 is 12, and 3 times 4 is 12. Understanding factor pairs is fundamental in number theory and helps with simplifying fractions and other arithmetic operations. In mathematics, a multiple is a result of multiplying a number by an integer. Essentially, multiples are found by skip counting. For example, the multiples of 3, 6, 9, 12, and so on, because we are just adding 3 each time, or we're multiplying 3 by 1, 3 by 2, 3 by 3, 3 by 4, and so on. A prime number, it has exactly two factors, 1 and itself. A composite number has more than two factors. The number 1 is tricky. It's neither prime nor composite. Providing number charts for students can be a great tool to help them understand and locate multiples, prime numbers, composite numbers, as well as identifying patterns. And it's so visual, and they're more likely to remember and internalize the information. All right. Students use properties of operations to calculate products of whole numbers, using increasingly sophisticated strategies based on the properties to solve multiplication and division problems involving single-digit factors. By comparing a variety of solution strategies, students learn the relationship between multiplication and division. Do you remember when you learned about the properties of operations? I think I was in middle school, and I think I had to know the names, but honestly, I don't think I had any idea what they were really about. But today's standards as we've heard in the fourth grade standards earlier in this workshop, today's standards call for students in elementary school to really understand the underlying concepts of the properties of operations. It's not so much that they know the name, though there's nothing wrong with giving them the name, and I think that's empowering, and they're going to use the name later, so we might as well. But it's really about them understanding the underlying big ideas behind the properties. Let's do a little quiz. Are you up for it? Let's call this quiz, do you know the properties, or guess the property? Okay, here we go. Guess this property. What is this equation modeling for us? Did you guess the identity property? The product of any number and 1 is that number. And let's look at how this visual really supports the concept of the identity property. There are 4 groups of 1. 4 times 1 is 4. Let's look at another one. Guess the property. Did you guess the 0 property? The product of any number and 0 is 0. Let's look at a visual to support that thinking. 4 groups of 0, there's nothing in those groups, equals 0. Let's try another one. Guess the property. Did you guess the associative property? You can group factors in different ways and still get the same product. Factors can associate in different ways. Look at how this visual, I love this one, supports this big idea. Let's look at another one. Guess the property. Did you guess the commutative? I'm stumbling over that word. Property? Commutative. Sorry, my brain just froze. When you change the order of the factors, the product stays the same. Another great visual. We just kind of move our head or rotate the example. Let's look at another one. Can you guess the property? The distributive property. Oh, I wish I knew this one when I was in elementary school. This would have helped me with learning my multiplication facts. Multiplying a sum by a number is the same as multiplying each add-in by the number and then adding the products. For example, in third grade, when I was memorizing my multiplication facts, and I wonder if this is the same for you, I did memorize that 6 times 7 was 42. And I knew that fact for a while, but then probably after the time that that quiz was happening, I forgot the fact and I didn't really know what multiplication was. So I couldn't get back to what the answer was without a calculator or without looking at a multiplication chart. But if I had really understood multiplication in third grade and knew, well, I don't know 6 times 7, but I do remember 6 times 5, that's 30. And 6 times 2, that's 12. And I can combine that 30 and that 12 together to get my 42. If I could have realized conceptually what multiplication is and that I could have cut apart or decomposed the 7 into a 5 and a 2, or there's other ways I could have decomposed it, 3 and 4, 6 and 1, I could have figured out the answer very quickly. Here's a great model demonstrating the distributive property. All right, we've done a real deep dive in all things multiplication. I think it's time to move on to division. So again, we're going to watch an amazing video by Graham Fletcher helping us understand the progression of division. Let me get us there.
Understanding we just saw should have been happening in third grade,
All right, sorry.
but it might
I'm
not be
going to
mastered.
back it
In
up.
fourth grade,
Here we go. Let's make it large and enjoy.
of all the things that students must learn by the time they leave elementary school, division might be one of the toughest. So here we look to tackle the progression of division, and it starts in third grade. So take this for example, 12 divided by 4. Let's see what happens. Well, we have two completely different models. And what this says is that the context, the story of the problem, plays a large part in developing students' conceptual understanding. In one, we have 12 bears with 4 in each group, which gives us 3 groups, and 12 bears shared with 4 friends, which leaves us 3 with each group. One model, well, that's measurement or repeated subtraction. The other is fair share, which I think we're all pretty familiar with. In one example, we have the group is unknown, and in the other, the size of the group is unknown. As students begin to develop their understanding of division, they probably begin to really rely on this fair share model. But 54, that's going to take a long time using fair share. So we need to put students in a place where they begin to become more flexible and efficient thinkers. So they might begin, instead of doing one by one, they might say, I'm going to take out 5 and put 5 in each group to start. Then, with their remaining pieces, they might put 2 in each group, and so on. So within each group of 6, they've placed a group of 5, a group of 2, and another group of 2. So when you take 54 and you divide it into 6 groups, you get 9 in each group. Now here students are making the connection between the concrete, the representation, and the abstract. And you know what? It all makes sense because students are building these pieces conceptually. As students begin to explore again in third grade, they deal with quotients which are greater than 10. Here students might begin to explore the idea of division with base 10 blocks. So they'll start with 72, and instead of putting it into three groups, they'll put it into three rows. They'll start by placing 10 in each row, then 10 in each row, and then they have that 10, and in order to place it in each row, they need to decompose it, make a fair trade. So you can see that when we take 72 and we divide it into three rows, we have 24 in each row. And then we want to make that connection from the concrete with the base 10 blocks to the representation. And how do we record our representation in a written expression? And some students might begin to collectively group their tens, and that's where the 20 came from. The best part about this is that students are making a connection back to multiplication by using the distributive property, and they're seeing it visually. In fourth grade, yeah, that's right, all that understanding we just saw should have been happening in third grade. But it might not be mastered. But in fourth grade, students will take 4-digit dividends and 1-digit divisors and begin to extend their understanding of division. But one thing has to be taking place, and that's continually making the connection between models and representations and written expressions. Here we'll take 144 and divide it into 9 groups, one into each group, and so on and so on and so on. Again, that fair share model. But what does that model look like as a written expression? Well, here are the students repeatedly removing groups of 9 from the 144. Now, is this efficient? No, not at all. But it's really important that students work through this step and they realize what efficient and non-efficient thinking looks like. So after students do the example of 144 divided by 9, we might throw them in a place with this number where the dividend is 3,672. Well, they start removing groups of 9 and immediately they say, oh wow, I'm going to be here forever. This is going to take the longest time. Can I take out a group of 100? Sure you can. You can take out whatever groups you want. So they can take out a group of 100, a group of 200, and then another group of 100 nines, and then a group of 6 nines. Students have to make sense of the mathematics, and we can't tell them what to do. So here, they're removing their partial quotients. So from the expression, they go ahead and create an area model. And what's beautiful about this area model is that it connects back to multiplication, except it's the area model for partial quotients. Then, as students begin to dive into fifth grade, they extend this understanding.
All right, we're going to pause there. Let me get us back to where we are. Wasn't that a fantastic video? Again, I watch it multiple times because he really does a great job explaining the progression of division. All right, so let's look at fourth grade fraction standards. I'm going to move on because we looked at some of our division standards within the earlier segment, and we're really going to take a deeper dive into division in our next Keeping It Going in fourth grade on demand math workshop. So now let's change gears and move to fractions. Fourth grade fraction standards. Notice on the slide that grade 4 expectations in this domain are limited to fractions with denominators 2, 3, 4, 5, 6, 8, 10, 12, and 100. This is very intentional. We want to help students make the relationships between 2, 4, 6, 8, 10, and 12, and 100. We want them to make relationships between 5, 10, and 100 in the denominator. There's 3 fraction models. The 3 main types are area region model. Most teachers spend the most time, honestly, in their classes on these. Those are the pizza and the brownie problems. They're the bar model, the circle model. Students are examining the equal fractional parts of a whole. Next up, which is very important in fourth grade, and it started as a standard in third grade, is the measurement or linear model. It does need equal time. It often doesn't get it, but it's equally as important. And this model helps students to think about ordering fractions for comparing them and for equivalency purposes. And the last type, which honestly does not need a lot of time and is not in our standards very much, is the set model. And that's simply seeing discrete objects that are their own whole. For example, 1/4 of those balls is a basketball, or 3/4 of the balls are soccer balls. We don't need to spend a lot of time on those. Okay, let's take a deep dive in our favorite fraction models for math tools. All right. These are the tools we really want to provide for our students. Okay, let's move on. Our favorite are fraction strips. So fraction strips are produced, or fraction bars, by many educational companies, and they typically come with the fractional name pre-printed on each section. So the benefit of using fraction strips to support our students' understanding of the area or region model is that students can compare the sizes. They're very easy and visual to look at comparing the size. So it takes something abstract, like if I was to ask you, well, which one is larger, a third or a fourth? And if you were like me in elementary school and I did not have visuals, fractions were very abstract and I really did not know. I had to do some work finding a common denominator to figure it out. But now I've worked with models and tools that I can quickly say in my brain, well, I know 1/3 is larger because thirds are larger than fourths, because I can pull up examples in my brain of tools I've used. And that's what we want for students. We want them to internalize all their experiences with the models. So I wanted to share that our very favorite fraction strip that's produced is by Marilyn Burns, and it's called the Marilyn Burns Fraction Kit. And when you order it from a company called Heinemann, so Heinemann.com, when you order the kit, teachers get multiple sets of magnetic, long-lasting, sturdy fraction strips that you can cut apart and use. You know, if you have a file cabinet that's magnetic, you can put it on there and use it for visual representation and teaching. If your whiteboard is magnetic, you can put it on there. They're wonderful. But not only that, you will get a set of 30 different paper colored strips that are the same colors as those magnets and the same length. And the beauty is that students make their own fraction kit out of the paper strips. They also get a long baggie, each student does, so that their fraction kit pieces can go inside. Now, here's a caveat. It does take time for students to make their fraction kit. They are cutting and labeling their pieces. Here's a recommendation: have them write their initials on the back of each of their pieces, because inevitably some might end up on the floor. And then it's a quick way to say, oh, here's your piece. Because in this kit comes a lot of games to play with their fraction pieces and fractional dice, and there's lessons. In fact, the first lesson is how to make the fraction kit. So while you're leading students through how to cut apart and make their kit, you're showing the relationship between the halves and the fourths and the eighths and the sixteenths and the thirds and the sixth and so on. So it does take time, but in our experience, it is it's time worthwhile. It's worthwhile time. All right, let's continue on. So what else do we recommend? Cuisinart rods. Oh my goodness, fantastic. Wooden rods. The beauty in Cuisinart rods, they are not pre-printed, and we're not going to do any writing on them. So we can be flexible and change what the hole is. We might say, for example, if the hole was the red rod, that's the second one. If that is our whole, what would we call the white little rod? And it takes, you would see if you had your hands on these, it takes exactly two of those to equal the red. So we call them halves. So there's lots and lots and lots of different ways to compare the relationship between the sizes of the rods. It's very intentional, and you can do a lot of fraction understanding with them. Another one of our favorites, oh my goodness, definitely one of my favorites, pattern blocks. So again, the beauty in pattern blocks is they are also not labeled. They're usually used for geometry, but they are hands down a fantastic tool for fractions. We're not going to write on them because we can be flexible in our thinking and change what our whole is. We might say, well, if the yellow hexagon is our whole, what would we call the red trapezoid? And if you had your hands on them, and this is what we'd have students doing, exploring, they would see that exactly two red trapezoids fit on the area or the surface or the region of the yellow hexagon. So therefore, one red trapezoid would be a half. And again, we can be flexible in our thinking, and we can say, well, if the red trapezoid equals one whole, what would a green triangle equal? And again, if students had their hands on these, they would see that the green triangles, three of them fit perfectly on top of, they take up the same region as the red trapezoid, so therefore they're 1/3. Oh, it's a fantastic tool. What else do we recommend? Real life measuring tool for fractions, measuring cups. A clock can be used. So, what fractional part of an hour is 15 minutes? 1/4. So, lots of different opportunities for learning there. Let's start looking at some of the fraction standards. Extend understanding of fraction equivalence and ordering. Explain why fraction AB is equivalent to a fraction n times A, n times B, by using visual fraction models with attention to how the number and size of the parts differ even though the two fractions themselves are the same size. Use this principle to recognize and generate equivalent fractions. So that visual representation shows what that language means. Let's look at another one. Extend understanding of fraction equivalence and ordering. Compare two fractions with different numerators and different denominators by creating common numerators or denominators, or comparing to a benchmark fraction such as a half. Recognize that when comparisons are valid only when the two fractions refer to the same whole. So, for example, if I said, which candy bar would you want half of? And maybe I had like a king size chocolate bar and then a little mini chocolate bar. That's a time when we're not comparing to the same size whole. So, a half of one and a half of the other is very different, right? So, they're saying the comparisons are only valid when the two fractions refer to the same whole. Record the results of comparisons with symbols greater than, equal to, and less than, and justify the conclusion by using a visual fraction model. Let's explore strategies that we can use with our students to support this standard. Strategy 1, comparing unit fractions. So here, this is a strategy we teach students, that whenever they come across two fractions and they're both unit fractions, that means there's a 1 in the numerator. So whenever we come across that situation, we can use this strategy. 1/10, that's my pink example, is less than 1/3 because 10 pieces are much smaller than 3 pieces of the whole. Now, in this example, our wholes are different sizes. I recognize the pink circles, that representation is larger than the green piece circle. So we're comparing the 1/10 in comparison. to the 10 tenths, and we're comparing the 1/3 in the comparison of 3/3. Does that make sense? Um, because this is kind of like that candy bar example. One is a little larger than the other. So we say to students, we're just looking at, comparing within the circles. So we can see that the tenths are cut into smaller pieces, and thirds, because that's a larger number, thirds are cut into larger pieces because 3 is smaller than 10. So it's less cuts. So a 1 out of 10 is going to be much smaller than a 1 out of 3. So that's comparing unit fractions. Let's look at another one. Strategy 2, comparing fractions with common numerators. Okay, we just looked at unit fractions, so 1 in the numerator. Now let's use a strategy where the two fractions have the same numerator. Here it happens to be 2. We've got 2/4 and 2/6. So we can use this strategy, but when we recognize whatever the number is, it could have been 3 and 3, it could have been 4 and 4, whatever. This time it's 2 and 2 in the numerator. Here's a strategy to help us figure out which one's larger. 2/4 is more than 2/6 because 2 out of 4 is more than 2 out of 6. 2 out of 4, there's only 2 pieces missing. 2 out of 6, wow, there were 4 pieces missing. Do you see how we can use reasoning to figure out which one is larger? Let's look at another one. Compare fractions with common denominators. Okay, now we're looking at that bottom number, so the 6. So we're looking at 4/6 and we're looking at 1/6. So we can use this strategy whenever our two fractions have the same denominator, whatever that denominator is. It could have been eighths, could have been tenths, could have been fourths, but in this one it's 6. And I could say to myself, oh, well, 4/6 is more than 1/6 because 4 out of 6 is more than 1 out of 6. Or I could say, well, 4/6, wow, that's only 2/6 away from a whole. And 1/6, wow, that's 5/6 away from a whole. That's further. So 4/6 is more. Let's look at another one. Compare fractions that are 1 unit away from one whole. So we can use this strategy when we notice both of our fractions just have one part missing to get to a whole. So I'm looking at 3/4 and I'm looking at 5/6, and I know 3/4 just needs 1/4 more and it's a whole, and 5/6 just needs 1/6 more and it would be a whole. So I can compare these two fractions. 3/4 is less than 5/6 because they are both 1 unit away from a whole, but 6 are smaller than fourths. So 3/4 must be smaller and 5/6 must be larger because that 1/6 is a smaller part and I'm getting closer to being a whole. Let's look at one more. I love this one. Compare fractions to 1/2. So this is a great strategy. So often we say in math, we can use 1/2 as a benchmark. And so we can compare fractions to 1/2 in some situations to help us know which one's larger or smaller. So in this example, we have 2/6 and we have 4/6. They're both one part away from 1/2. 2/6 is less than 4/6 because 2/6 is 1 unit less, or 1/6 less, because 3/6 is the same as 1/2, than half. And 4/6 is 1 unit more than a half. I can even like close my eyes a little bit on the 4/6 and take away that extra sixth and see the half. I know that 3/6 is equal to a half, so 4/6 is 1 more part than a half. So 4/6 is more and 2/6 is less. Isn't that a great strategy? Build fractions from unit fractions. So here's another fourth grade standard. Understand a fraction AB with A is greater than 1 as a sum of fractions 1 over B. So lots of times educators look at that standard and say, what in the world is that talking about? Let's look at the visual that demonstrates what this is talking about. Do you see how 1 or 3/3, they're equivalent, is made up of a third, and a third? And we can keep going. 4/3, 5/3, 6/3. Oh, that's 2. 7/3, 8/3, 9/3. Oh, that's 3. A routine you want to use with your students that we will talk about in our next on-demand video for grade 4. It's called Counting Around the Room, is a fantastic routine. So you could use thirds, and you might say to students, all right, let's all get in a circle. And this is a little preview of our next on-demand video for grade 4 called Keeping It Going in grade 4. You'd say, okay, we're all going to count around the room. We're going to count by thirds. So everybody, first kid's going to say 1/3. The next kid's going to add on to that 2/3, 3/3, or they can say 1, 4/3, 5/3, 6/3, or they could say 2. And you say, what number do you think we'll land on when everybody has, added on 1/3? A great visual and auditorial um, example of this standard. And a great tool for the teacher is have the kids count slowly, because you should be writing it on the board. You can write it like it is on the slide as a number line, or you can also, we've seen teachers write it in columns. It's up to you. Both models, I would do it multiple times, on different days. It's a short math routine. Count by 6, count by fourths. You can start at different numbers. You can say, if we started at 2 and we counted by 6 around the room, what would we end on? You can count backwards. So, okay, we'll share more about that one in the next video, but it's a great strategy to support the standard. Okay, build fractions from unit fractions. Understand addition and subtraction of fractions as joining and separating parts, referring to the same whole. I'll let you look at this one for a moment. Mary ate 1/8 of the chocolate bar. Nancy ate 2/8 of the chocolate bar. They ate 3/8 of a chocolate bar. So there's a context with it. Another one, build fractions from unit fractions. Decompose a fraction into a sum of fractions with the same denominator in more than one way. Recording each decomposition just means breaking apart by an equation. Justify decompositions, for example, by using a visual fraction model. Their example was 3/8 can equal 1/8 plus 1/8 plus 1/8. 3/8 can also equal or can be decomposed as 1/8 plus 2/8. Also can be decomposed 2/1/8 equals, another example, sorry. 2/1/8 equals 1 plus 1 and 1/8. Another example, 8/8 plus 8/8 plus 1/8. So again, sometimes teachers struggle, and I completely understand why, with the language of the standard, but let's look at the visual model. That always unlocks a lot for me. There are 2 ways really, to think about 3/10. 3/10 can be decomposed into 1/10, 1/10, and 1/10. 3/10 can be decomposed into 2/10 and 1/10. So a really simple example, but to help us visualize. Let's look at another one. Build fractions from unit fractions. Add and subtract mixed numbers with like denominators by replacing each mixed number with an equivalent fraction and or by using those properties of operations and the relationship between addition and subtraction. I'll let you read the visual. All right, let's look at our next one. build fractions from unit fractions, solve word problems involving addition and subtraction of fractions referring to the same whole, and having like denominators by using visual fraction models and equations to represent the problem. Let's look at a context for this. At the end of the year, the teacher was cleaning out his classroom closet. He found several boxes of markers that were 6/8 full. He was able to reorganize the markers so that each box was completely full. He was able to make 3 full boxes of markers with none left over. How many boxes of markers that were 6/8 full did he combine? There we have a visual. We've got 6/8 plus 6/8 equals 12/8 plus 6/8 equals 18/8 plus 6/8 equals 24/8, which equals 4 boxes of markers. All right. Let's watch. This is our last instructional part, and then we're going to move on to math routines. So feel free to, again, chunk this if it works best for you. We're going to watch another amazing video from Graham Fletcher on fractions. So let me get us going. Here we go.
If you've been sitting on a big idea and you're finally ready to launch that business that you've been dreaming about, I've got something you need to hear. Every day I talk to small.
There we go.
Fractions. The very sound of the word, well, it kind of freaks most of us out. So here, I'm going to take a stab at explaining the progression of fractions. And it begins in first grade. And it starts with a crazy word, partition. And I think that students should be able to use that word as well. So in first grade, students should be able to partition squares and rectangles into halves and quarters, which can also be represented or called fourths. The vocabulary development here is the biggest piece in first grade. So they could also say a quarter of, a fourth of, or a half of. In second grade, students build on their understanding of halves, quarters, and fourths, and they're introduced to the idea of thirds. Again, they should be using that term, thirds or a third of. When students leave second grade, a big piece of understanding they should leave with is though even though shapes can appear different, they actually can have the same size. So this brings us to third grade. It's a really big year for the development of fractions because here students are beginning to really truly develop that meaning of a fraction. And it's the first time that students see fractions written as a symbol. So even though we're talking about symbols, we really need to place our emphasis as teachers on the visual representation of fractions. So how can we do that? Well, one way we can do that is by creating a length model. Here you see that we've taken a strip of paper and folded it up into 4 parts. Another way, which isn't really explored in third grade, is the use of a set model. Here in this set model, you can see that 3/4 of the bears are green. And the last way that we can represent fractions is one that I think we're all pretty much familiar with, and that's the area model. Here, 3/4 of our square is yellow. As students are building this understanding, we need to make a connection back to their understanding of what they have with whole numbers. So just as whole numbers, take for example this number 4, is built from units of 1, fractions, in this case 3/4, is built from 3 1/4, a fourth plus a fourth plus a fourth. Big understanding here. Let's go back to that length model. Well, that length model is a really powerful tool because it helps build students' understanding, which can also be done through a number line. Here's another number line. What number is the question mark? Here, let me help. Wait a minute, that's greater than 1. Well, in third grade, students need to see that fractions can also represent numbers greater than 1. It's the sum of unit fractions. So we might want to get students to begin counting with fractions. 1/3, 2/3, 1, 4/3, 5/3, 2. Let's get our students counting by fractions. Counting circles are a great tool to get students understanding and seeing the sum of unit fractions and that repetition and the structure of numbers. So as students begin to learn dividing in parts of a whole and partitioning up shapes, they begin to explore this idea of equivalent fractions. So here we're going to take 4 lines and we're going to divide them up. We're going to partition them all into equal parts. And as we partition them all up into equal parts, we begin to see that, hey, some of these line up a little bit. Here, students are beginning to explore the idea of equivalent fractions. So 1/2 is equal to 2/4, which is equal to 3/6, which is really the same as 4/8. The big piece here that students really need to see and we need to push and promote is that the size of the whole doesn't change, just the size of the parts do. But even though we're talking about fractions, students need to also understand that whole numbers can also be written as fractions. Take, for example, the number 1. Here's 3 ways that we can represent that number 1. As students begin to build that understanding and they continue to build their understanding, we compare fractions. Here, 1/4 is greater than 1/2. Now you might be thinking I'm crazy, but I'm not. See, 1/4 is, yep, 1/4 is greater than 1/2. It comes back to this understanding that students need to see that we have to be talking about the same size whole. So let's compare these two fractions, 3/4 and 5/4. Well, here we see that 1/4 is a rhombus. So if we have 3 1/4, that's actually less than 5 1/4. And that's a common denominator strategy. Another way we can compare fractions is if we have a common numerator. Here we have 1 as a common numerator. Yeah, common numerator. It doesn't quite sound right, but here students have this understanding and should be building this understanding of a common denominator and common numerator. Here students can see that 1/6 is actually a smaller piece than 1/3, and therefore it's less. So in 4th grade, we continue to build students' understanding of comparing fractions. They come to us with this understanding of common denominators, common numerators, and here's another strategy students can use to compare 7/8 and 11/12. Now, they're both missing one part from a whole. But students know, because of their understanding of a unit fraction, that an 1/8 is actually larger than a 1/12, and therefore it's farther away, it's missing a greater piece of its whole. And the last strategy we can use to compare fractions is with a benchmark. Here we'll use a benchmark of 1/2. Well, we know that 4/8 is equal to 1/2, and 1/2 of 5 is 2 1/2. Yep, we're not using any butterflies here, and butterflies have no place with comparing fractions. So we have 4 strategies for comparing fractions, but let's go back and revisit that idea of building equivalents. Well, here we have a 1/2, and if we take our 1/2 and we multiply it by 2, by dividing it, we can actually see that 2/4 is the same as a 1/2. And if we repeat that procedure, we see that we have 4/8. Here, this area model helps students visually see equivalent fractions. Now, after students have explored with fractions lots of times, they begin to see this pattern in numbers. And I think it's our job as the teacher to kind of allow them to see this. So students begin to see that whatever we do to the numerator, we do to the denominator. But I think that it's important that kids come up with that understanding, not just us telling them. There's a whole bunch happening here in this crazy world of fractions.
All right. Let's get rid of this. Another great video. Oh my goodness. He talked about a lot of things we had talked about as well. All right, let's get back into here. Another one to watch multiple times. All right, moving on. So, whew, is your brain tired yet? Okay. You should have also received a slide deck full of math routines for your grade level. We love kicking off math class with a 5 to 15-minute math routine. And as you see on this slide, we have many different types of math routines to choose from to keep it fresh and to engage our mathematicians in meaningful mathematics. So let's watch a video which highlights the math routines that we included for you in the slide deck of quick images, which does not belong, array images, and visual patterns. Enjoy. In this math workshop, we will examine math routines as a key tool in our math toolbox of strategies to support our students. We will share what they are, why we should facilitate them, when to facilitate them, where and how. Whether you are an educator new to teaching math, a homeschool parent teaching your young mathematician, or a parent interested in supporting your child, or an experienced math teacher, our hope is that this math workshop will provide support and guidance for you as you teach your children mathematics. What are math routines? Math routines are a daily 5 to 15-minute routine. They are structured, repeatable activities in mathematics classrooms that provide a framework for engaging students in thinking, reasoning, and communication. They offer a predictable structure that supports both teachers and students, promoting deeper mathematical understanding and student agency. The teacher's role is to provide the math routine and to facilitate the discussion. Teachers do a lot of listening and learning about their students' mathematical understanding. The student's role in math routines is to think, reason, share, and learn from each other. They're honestly our favorite part of math class. This comes from educators, students, and myself. What are some math routines? Well, just to name a few, number talks, subitizing, quick images, which doesn't belong, tell me all you can, visual patterns, array images, same and different, guess the rule, and share your solution. And there's more, but those are just to name some. When should a teacher add math routines to their schedule? Math routines are a great way to warm up students' mathematical brains at the beginning of math class. They're naturally a great transition because students love to engage in them. I remember a first grade classroom that I was coaching in a while back, and the first grade teacher had students meet at the rug right after recess or break for their math routine time. And I was just so impressed with how eager the students were to get back inside, get settled quietly on the rug. They were so excited to participate in their math routine. Conversely, math routines can also be implemented at the conclusion of math class as an exit ticket. Students could record their responses in a math journal, on a post-it note, on a note card, on an individual whiteboard, or simply do a turn and talk with a partner. Maybe there's an odd 10 minutes in your class schedule for the day in between specials or subjects where a math routine would be perfect. Honestly, there's no wrong time to engage your students in a 5 to 15-minute math routine. Parents even love to see math routines modeled with them themselves at back to school nights. Where to engage your students with math routines? The answer lies in your particular situation and space. Educators take their physical space, their classroom, into consideration, whether they're gifted to have a large whiteboard projector, and if they have a rug where students can meet as a mathematical community, knowing they're just going to be there 5 to 15 minutes. So it's not too long, short and sweet. Additionally, teachers may want to consider what math tools would be valuable to be posted near that area, wherever they're going to have, where they're going to facilitate their math routine. For example, in kindergarten, I've seen Teachers, of course, kindergarten teachers always have a rug. They'll have a large number path posted easily within view of the kindergartner's eyes to support their time in the math routine. Also, in second grade classrooms, I've seen teachers post a large 100 chart nearby the area where the students were engaged in math routines. So I know teachers just consider what visual representations or models might support my students' thinking and being successful during this math routine. Educators want to consider how where they facilitate the math routine impacts their students' ability for communication. Because we really want to foster students thinking and as they're sharing with their classmates and listening to their classmates. So sometimes teachers don't want their students back at their desks where they're more spread out and where they're more likely to fiddle with things inside their desk and not give their full attention to the discussion that's taking place during the math routine. But honestly, teachers really have to think about their space and what works best. How to facilitate math routines. Well, there are nuances within particular math routines. We have more math workshop videos on the various math routines that we have on our website, themathworkshop.net. So, for example, with quick images, which are in essence a type of number talk, we only show the image to students for about 3 seconds, and then we hide the image. And the reason for this is because we're trying to gently influence our students not to count the items on the screen, but to see the groups of items. This is called subitizing. Each math routine has its own slight nuance, but in a nutshell, all math routines should be short and sweet. They should happen daily. That's why they're powerful, because the benefits collect over time for students and their understanding. And now let's look at some examples of some of the math routines that we can provide for our students. This is an example of a quick image. So you see dots. Students would be shown these dots for about 3 seconds. So you're seeing them for a lot longer. And they would be asked to consider two questions. First, how many do you see? And then, how did you see them? And again, we have more math workshop videos that dig deeper into each math routine, but this is just an overview. So some students might say, I saw 4 and 4 more, and I knew that made 8. So the teacher is the one doing the recording, listening to students. And the teacher might ask, who else saw it that way? And sometimes teachers teach their students the sign language, which means me also or me too. Essentially, I saw it that way too. It's a quiet way, for a nonverbal way, that the teacher can look around and see who else saw the 4 and 4. But then the teacher asks a wonderful follow-up question. Who saw it another way? I love that question because it's really a positive supposition that there are other ways to decompose this 8. So by asking it as who saw it another way, it's really inviting students to go, oh, there must be other ways. So then maybe another student might say, oh, I saw 2 and 2 and 2 and 2, and that makes 8. And again, the teacher is the one who's quickly recording, possibly, if the teacher makes that decision. Probably an early beginning of kindergarten, teacher might not be recording yet. They're just warming up the kids, getting used to this routine. Definitely later in kindergarten, the teacher's going to be recording these, the groupings and recording with equations and the numbers. And upper grades are probably, it's more, they should be doing that too. And again, the teacher's going to say, who saw it that way? And other kids might be doing the silent sign language for me too, that you would teach the class. And again, the teacher's going to ask that follow-up question, who saw it another way? Or even if no one says they saw it another way. You could say, push them and say, can you push yourself right now to see it another way? And still, some other students might say, well, I knew it was 8 because 1 and 1 make 2, and 3 and 3 make 6, and 2 and 6 make 8. And depending on the age of the students, again, teacher may want to record that corresponding equation and name the strategy so that that student was adding by doubles. So by naming the strategies, we can empower our students to now have this common language, because the 1 and 1 make 2, 3 and 3, 6, those are doubles. And knowing the names of strategies can be really powerful for students to be able to make connections with each other and be able to use that strategy again. So the superpower of quick images, and quick images honestly can be used K through adulthood. Um, the superpower of quick images is that students are seeing all the ways that a number, and in this example, it was 8, can be decomposed or broken apart. And on this slide, we're seeing 3 examples from students, and there are others, but we're looking at 3 examples. And this is a very important idea, that this subitizing, where students are seeing groups within a larger number, what sets make up that number, can make up that number. This actually begins to lay the foundation for success later in algebra. Now, it's really important that the dots, for using dot images for our quick images, that they're very strategically placed in purposeful ways. And there are resources out there for you on what dot arrangements seem to elicit groupings. So we do have more information on our website about this. So I would encourage you to explore that if these dot images, these quick images, are new to you. Let's look at another math routine. This one's called Which Does Not Belong. And in this math routine, the teacher usually shares a collection of 4 items. It could be numbers, shapes, photos, or pictures, sometimes words, and asks the students which does not belong, and asks the students to think about why. Why does it not belong? So here's an example of a which does not belong. It would be appropriate for kindergarten, maybe first graders who need to revisit some early numeracy work, or, let's be honest, there's going to be other students in other grades that perhaps for a multitude of reasons, some foundational mathematical ideas were not in place, that this would be beneficial to continue to work on. I'm going to pause so you can consider, out of those 4 10 frames, which does not belong and why. Some students might say that the top left 10 frame doesn't belong because the 5 red counters spill over into the 2 rows. So we see 4 and 1. Whereas in all of the other examples, the 5 is in a consecutive row. Some other students might say that the bottom right example of the 10 frame is the one that doesn't belong because all of the red counters are on the bottom row. And for the other examples, mostly the red counters are on the top row. Both responses are acceptable. The beauty of all math routines is that the thinking and the reasoning comes from the students. If you don't get responses that you think are really digging that deep, revisit the image later, another week, another month, come back to it another time. This is not really a time for you to teach or to show your thinking, because honestly, I think we've seen as educators that doesn't stick with kids. So revisit this another time, and maybe your kids are further along in their thinking, and then they might see what you were hoping in your mind they would see. In a lot of examples of which does not belong from various educational resources, you're going to see an A, B, C, D labeling. We intentionally did not label our collection of which does not belong because we strategically wanted students using positional words, which are in the kindergarten math standards, next to, above, below. So we want to give students that opportunity to use that kind of language. So they might say the top left, the top row, the bottom right, and so on. Here's another example of the math routine which does not belong. Which one do you think doesn't belong? Did I give you enough time? These are pattern blocks. And as a side note, you're probably going to want to have, I would say, really for all, I would say K through 6 should have pattern blocks because they're foundational for kindergarten, first grade, second grade, for shapes, talking about different characteristics and attributes of shapes, but also fourth, fifth, and sixth grade can use pattern blocks to work with fractions. And if you watch our videos that we have on our website or on our YouTube channel, we have a math tools video for fourth, fifth, and sixth grade that touches on this. So which one did you think didn't belong? Oh, and one more side note is the graphics that I'm using on this slide, you can access for free on the Math Learning Center website. They have interactive tools, which are a great way to model the tools, these manipulatives you would have in your classroom. All right, let's get to the answers. So some students might say that the yellow hexagon on the bottom right corner doesn't belong because all of the other options are either a trapezoid, the red shape is a trapezoid, or they're making a trapezoid. The shapes are composed together to make a trapezoid. Other students might say that the green triangle and the blue rhombus in the top right doesn't belong because it's the only option that has two colors, whereas the other options just have one color represented. Both answers are completely appropriate, and students would be using reasoning to come to those conclusions, and there could be more answers. Those are just two. Here's a sixth grade example for which does not belong. In this example, the pinkish purple rectangular array is the only choice that doesn't represent 9. The superpower of the which does not belong math routine is that the options we present to our students should have multiple answers. They don't always work out that way, but most often they do. And that's really the beauty of it. So that takes thoughtful consideration on our part to design problems where there's multiple opportunities for reasoning. Next up is array images. With this math routine, the students will be shown an image and asked to consider some questions. The teacher should consider if math tools like manipulatives or grid paper, maybe individual whiteboards, would that be supportive to students' thinking and exploration during this math routine? And it's going to depend on the image each time. Depending on the time frame, the teacher will also adjust the number of questions explored. They will invite students, either independently or with partners or in small groups, to generate equations that match images. And possibly, if there's time permitting, students could do a gallery walk, viewing different students' equations, or pass the paper to examine equations to compare the equations. The images in this routine, though, I wanted you to know, are not intended to be flashed like the quick images routine. So we're just going to look at them and keep them up and be comfortable with them and see them. With the array images math routine, we recommend educators use the look, think, talk strategy. And honestly, this can really be used throughout the day in a classroom with multiple situations. So look, show students an intriguing image and pose a mathematical question. Think, give students a chance to think. Talk, engage students in a discussion about the image and questions. Here are some array image questions that a teacher could consider. And again, it's based on the student's age, the image you're using, how much time you have. But here are some of the questions you could choose from. What do you notice and wonder? How many are there without counting? That's what we're really pushing to. Now, some students might be just comfortable at this point counting, so we don't make them feel bad or shame them for any reason for counting. But we want to gently try to highlight the strategies that come from students that don't involve counting. That's where we're going to hover and give a little more time and energy to, because again, it's related to the subitizing, seeing groups of within a larger group. We might ask, can you see it a different way? What equation would match the way you see it? Is there another equation that would match the way you see it? And here's even a bonus question. If a student presents an equation that another student didn't come up with, can you push yourself to see how their equation also matches the picture and how? So once you get in the swing of doing this math routine, you'll come up with other questions too as they relate to the image. Let's look at one of these images. Depending on the age of our students, we might ask, especially if this was kindergarten, first grade, second grade, we might start with, what do you notice? So really, we're just entering, base level. Everybody in the room can be engaged because every child is going to notice something. Hey, Miss Brewer, I noticed there are dogs. Oh, I think the dogs are sitting on stairs. So we just want every student to be initially, again, we're just starting baseline, engaged. So what do they notice? Then you might and we're going to do this pretty quickly. We're not going to spend a lot of time on the what do you notice. The follow-up question might be, what are you wondering? Is it one family that has all these dogs? Where do they sleep? How much do they eat? Okay, so just give them a little bit of time to have that natural curiosity. What are your wonderings? Then we might get to, how many do you see? How do you know that? And again, we're not flashing this image. We let them look at the image. What equation would match the way you see it? Some students might say, I see 8 steps with 2 dogs on each step. So 8 times 2 equals 16. Okay, that might be a 3rd grade class, 4th grade, 5th grade. Another student might say, I saw 2 dogs on each of the 8 steps. So 2 plus 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 2 equals 16. The teacher can write the corresponding equations, maybe on chart paper nearby, or if this is displayed on an interactive whiteboard where you have the ability to record equations, I would strongly recommend doing that. All right, let's look at another one. Here's another array image. The teacher might decide that providing individual whiteboards with dry erase pens might be beneficial for this example. So the teacher's going to pre-think, do my students, would they need something to have access to this problem? Students would probably notice that the top row has 4 rolled items, and each remaining row below that has +1, +1 more, +1 more. So essentially, we end up with an equation that is 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11. With this problem, students probably would benefit from some place to record their thinking. That's a lot of math to do, mental math in our head without keeping a record of it somehow. I'm not saying it couldn't be done, but it might. Having a place to record our thinking might really be beneficial and open up the range of students that are successful with this problem. A follow-up question could be asked if, again, depending on the age of the students and if we feel it's appropriate to challenge them that day. How many rolled items do you predict would be in the 10th row? Why? How did you figure it out? Here's another example of array images math routine. Notice the questions that could be presented for students to use with this image. So the superpower of the array images math routine is it due to the nature of the questions, especially the first question on the slide, what do you notice and wonder? As I mentioned earlier, all students are going to be able to participate with that question, and it's going to initially get them engaged about the image. For this math workshop, let's examine one more math routine. Let's examine visual patterns. These are the visual pattern questions that teachers can choose to use. Some of them are similar to the last questions we just looked at. What do you notice? What do you wonder? What do you think you will see in the next step and why? That will make sense in a moment. Now that the next step is revealed, what do you think you will see next and why? How is the pattern changing? So let's look at an example. When using the visual patterns math routine, you will share with your students that they're going to be shown some steps in a pattern. Their job is to consider the questions that you choose to ask. So what do you notice? What do you wonder? And most importantly, the question we really want to hover around and have the most energy around is, what do you think you will see in the next step and why? We are looking at the first step in the pattern now. What do you think you will see in the next step and why? Here's the next step in the pattern. Does this represent what you predicted? What do you see happening from step 1 to step 2? How do you predict the pattern will grow for the third and final step? Here is the final step. Is this what you predicted? How has the pattern changed? Depending on the age of your students, they may be able to come up with a rule or statement on how the pattern is growing. You can challenge students to predict the next design. That would be the fourth step, or the 10th, or the 100th. So again, it's really age dependent design in this pattern. Here is the answer key. And in our examples that you can purchase from our website, we have the answer key for you for all of them. So in this growing pattern, step 1 has 4 blue squares, 1 purple square, and a total of 5 squares. Step 2 has 8 blue squares, 1 purple square, and 9 total squares. Step 3 has 12 blue squares, 1 purple square, and 13 total squares. So between the steps, we're seeing a +4, +4, +4. So the advanced rule for upper grade students would be, oh, sorry, I went too fast, 1 + 4n. Now, we do provide the answer key for you as a teacher, but I want you to hear me clearly. We're not suggesting you reveal the answers to the students. Again, the purpose of the math routine is to see what we get from students. So the answer key, it's not going to show up on a slide like this. I'm just doing this for this presentation. It will be in your notes that you will have, but it's just to help you facilitate the discussion if the discussion goes that way. Oh, Miss Brewer, I notice it's a +4 each time. And so you can have that information in the back of your head because you looked at the answer key, and you're going to be thinking about how am I going to record that? So maybe even drawing an arrow and doing +4, drawing an arrow +4. You, as the facilitator, you're going to be making those decisions on what should I record and how should I record it so that all my students in my class can get access into whichever student was sharing what they noticed. The awesome part about recording for students is that it really provides a link between that visual representation of the pattern and the abstract mathematics in the equation or in the table. And most students, honestly, are going to need that. Not all of your students, but it's really going to support most. I know I benefit from seeing the equations, the tables, matching what I see in the visual. It helps solidify my thinking. The visual pattern superpowers that are used in math help students develop a deeper understanding of mathematical concepts, build foundational skills, their problem solving, their reasoning. It's really laying the groundwork for algebraic thinking. We recommend that educators use talk moves as a facilitation strategy for promoting classroom discussions. These talk moves prove to be a game changer in promoting student agency. And I know the poster that is on display there says math talk moves, but here's a secret that you probably know. They can be used in any part of the day, any subject. So revoicing. Oh, so you're saying that you knew 4 plus 3 is 7 because you knew 3 plus 3 is 6 and um, you added one more. And it could be the teacher's revoicing, it could be another student's revoicing. Repeating is hands down my favorite. So here's how we recommend teachers use repeating. Not in a punitive way, which I have used this in teaching in a punitive way, and now I regret it. Johnny, can you repeat what Sally just shared? Oh, you can't because you weren't listening. Come on, Johnny. That's not how we recommend using repeating. Repeating is an invitation. Oh my goodness. Who heard Sergio's explanation of that visual pattern? Who heard it and can repeat it? Because that is worth repeating. And if no one heard, and we only use repeating when we think it's like a great idea, we do want to hover because we think, well, maybe a couple kids heard, but not everybody heard. So let's hover here for a minute. So then you say, Sergio, that was so awesome. Can you repeat that again? And then I'm going to ask again, I'm going to invite who heard what Sergio said and would like to repeat it. So I tell you what, our kids, they want to, most of them want to be talking. So if we're setting them up for success, hey, all you have to do is listen to Sergio, and then you can volunteer to repeat what he says. Then after that child, whoever you called on, repeated what Sergio said, you always go back to Sergio. Sergio, is that what you said? And, how did that kid do? And again, it's in a positive way. And because sometimes kids don't repeat what the child said, and Sergio can say, no, actually, this is what I said. And then you can give that child a second chance. Oh, okay. Can you repeat it now? So we're just really teaching kids there is value in listening to each other and to considering what each other says and being able to repeat it, to think about it. Um, I honestly believe, and I bet you do too, students can learn probably more from each other than they can just from me, the teacher, because there's so many of them. So let's empower them with that technique. I love reasoning. That's the next talk move, and that's math routines are all about reasoning. Do you agree with, do you disagree with why? How did you see it? Why did you see it that way? Can you explain that? Adding on is a favorite too. Who heard what Christine said and can add on to it? I'm always surprised, even down in kindergarten, that students have something to say about what Christine just said. It's amazing, but I've got to remember to ask the question. Who heard what Joe said and would like to add on to that thinking? And of course, wait time, something all of us need to work on, me included, and our favorite turn and talk. To summarize, remember that math routines are structured, repeatable activities in mathematics classrooms that provide a framework for engaging students in thinking, reasoning, and communication. They offer a predictable structure that supports both teachers and students, promoting deeper mathematical understanding and student agency, things we want from our mathematicians. They're honestly our favorite part of math class. We hear that from educators and students. Our hope is that you found this Math Routines Math Workshop useful in supporting you as you guide your mathematicians through math routines. We find math routines to be not only fun, as we've mentioned several times, and engaging. but extremely helpful in providing opportunities for students to make sense of math concepts and develop deeper mathematical understanding. Again, laying that foundational groundwork for algebraic thinking. We have more information on our website that you see on the screen, themathworkshop.net, about these various math routines that you see on the screen and others that we didn't have time to touch on during this math workshop. So feel free to go to our website, locate the resources page, which is there's a snapshot on the screen of a smaller part of the resources page, and you'll find more information under math routines. There's more videos, there's examples. So thank you for joining us, and we hope you have a terrific school year. Thank you, if no one's told you today, thank you for what you're doing for our students. All right, welcome back. Hopefully you found that helpful, and hopefully if you haven't used math routines, I'm hoping you're really excited now to use them. And if you have used them, maybe we added to your toolbox. Let's continue on. Okay, here we go. So also within that email that we sent you that had the link to this on-demand video, we shared with you these 3 games: equivalent fraction search game, product roll game, and no remainder game. We recommend that you teach your class how to play these games in a whole group way, possibly you modeling with maybe you against the class or you with another student, with a student, and then give your students the opportunity to play with partners, and then bring them back together and ask for what they noticed, what they're wondering, and what questions they have. Then you can feel free to put these games in a math center. You should have also received a set of geometry word wall cards. Math word walls can be a great scaffold to support our students with key academic vocabulary and concepts. And we know it's so important to have the word wall where students and the teacher can easily see the images and reference them regularly. I know there's something about that episodic memory. I remember being a 5th grade teacher, and I had a lot of word walls all around my classroom. And of course, for state testing, we had to take all of that down. But I can even just see some of my students still, they remembered where that vocabulary word was. And it was just like that episodic memory, even though it's gone now, but having used it, and it wasn't just wallpaper, there, nobody talked about it, but we would regularly reference it. I know that it stayed with them. So we're so excited to share that we have a part 2 in this series in supporting educators with 4th grade math. The second part of this series examines the remaining math standards that we really didn't have time to get to in this workshop, which is understanding the multiplication of fractions by whole numbers and understanding geometric figures that can be analyzed and classified by properties, as well as diving more into division, as well in this second Keeping It Going with 4th grade math workshop. We're also going to touch on the 3 math routines of Tell Me All You Can, Same and Different, and Counting Around the Room. So we hope that you register for this part 2 in the series. We want to thank you for your time and thank you for all you do for your students. We hope you have a fantastic school year. Please consider joining some of our other on-demand videos. We have amazing math routines. We have procedural fluency and conceptual understanding. We have rich task investigations. We have a fractions and decimals boot camp workshop. We have math strategies versus algorithms. What's the difference? Why are they both important? What are they? And we have small group and math centers and games. And if you see, if you're wondering, maybe there's something you want to take a deeper dive in that's not on the screen, shoot us an email and we'll consider, because we want to support you. So again, here's our website, themathworkshop.net, where we have lots of free resources for you, lots of free videos that are from our YouTube channel, and professional development offerings. So again, thank you for your time. We just really, again, hope you have a fantastic year and with your students, and we're here for you.